Hello and welcome to the first digital AMPOWER Report release event. My name is Matthias Schmidt-Lehr and I'm one of the 3 founding partners at AMPOWER, and I will guide you through today's presentation of the AMPOWER Report 2021. Today's event is the first of its kind, so we hope everything will work fine and you're able to see us and hear as well. If you have any questions during the presentation regarding the report, please write them into the message board so we can address them after the presentation in a short Q&A session. With me today are my 2 co-founding partners of the AMPOWER company, Dr. Maximilian Munsch and Dr. Eric Wisches. Max will guide us later through the key findings of this year's report. But first, I want to give you a very brief introduction of the history of the AMPOWER report. AMPOWER is a consultancy for additive manufacturing, founded in 2017 with the goal to enable users, also as suppliers of the industry, to be successful with additive manufacturing. In our projects, we used to work with several AM reports that are on the market, but we missed some key aspects in those reports. First of all, they were all based on data of supply chain of additive manufacturing. But we wanted to know how the users are utilizing the technology and how they see the forecast of 3D printing. Secondly, we were suspicious about some very optimistic forecasts that did not match our experience in the field in our projects. And thirdly, we wanted to be able to search through report data and through report files and charts faster online rather than scrolling down large PDF documents. All that together led to the introduction of our first AMPOWER report at Formnext 2019, where we published our very first own market report, which focused first completely on metal additive manufacturing. This report then had an update shortly after in April 2020, and today it's a great pleasure to introduce yet another update of the report along with the all-new polymer report. Now we are able to present to you a complete market overview of the global polymer and metal 3D printing market. Our combined market report contains more than 90 graphs and figures to break down the industry in the different segments. Most of our forecasts contain assessment of the supply chain and the user group. This means our forecast has 2 different values. One is reflecting expectations of suppliers, while the other represents the plans of real industrial users. In this year's 3rd edition, the AMPOWER report also is extended by more than 15 co-authors who contributed focus chapters on regional developments or R&D activities. This was especially important for us because we wanted to report about local developments by experts that are closest to the industry in their region. Also, our database keeps growing with every new update. We now have over 1,600 entries of AM suppliers in our database, and the application database contains now more than 80 real industrial applications in metal and in polymer. In this combined report, we took a deep dive into 18 different metal and polymer technologies and several future outlook technologies that will come in the next couple of years. Now, the main driver of the industry today is our applications. And in 2020, medical and space were really the leading user industries in polymer and also in metal. Automotive and aviation really had hard difficulties to continue growth, but medical and space companies were able to make significant developments towards final end parts. For this year's cover, we choose a Mars rover component, which was manufactured at Caltech by electron beam melting. And for the polymer report, we choose the most obvious part, the most obvious application, which showcases a 3D printing nasal swab. Those components were and are still printed in millions, and the production just seems to ramp up on multi-jet fusion systems, but also on resin systems. But the core of our report is the market data, and this is the main division for Max. Max will now give you an introduction and a quick tour through the key findings of the AMPOWER report. All right. Max, the stage is yours.
Thank you, Matthias, for the introduction. I'm Max Munsch, and I would like to start talking a bit about the report model before I come to present the key findings of our actual market data. So basis for our report are interviews with suppliers. So regarding the suppliers, we asked, for example, the system suppliers, how many machines they have installed overall, how many machines were sold in the past year, and how many machines will be sold in the coming 5 years. So for the metal additive manufacturing market, this is the graph on the left side, we have a coverage of about 96% of the overall installed base from primary sources. So we can speak directly to the different system suppliers. So 96% of these system suppliers provide us with direct input on how their past year was, and also how they see and how they predict the future of their company. And this value is important for us as it is the reference and basis for our data model, and also used to scale up the data. For the polymer AM section and the polymer market, this value is a bit lower at only around 82%. It's the report area when we just started, of course, in the first year edition. The additional 18% are covered through secondary sources, public records, or other publicly available sources. So in polymer AM, we're still growing this. And I would also like to stress in polymer AM, we also focus today on systems with a sales price above 10,000 euros. So we do not track the market of private consumers. We focus on the industrial use of the polymer AM technology. So taking the overall market data, we segment it into groups that you see on this slide to provide a better picture on certain details, of course. First of all, as already Matthias mentioned, we have to consider the two different interviewee groups that we have of suppliers and the buyers, so the users of the technology. So we do not only ask the suppliers on how many machines they sold, for example. We also ask the users of additive manufacturing. And we find this especially helpful and important to also reach out to the users to understand how their past year was. We can ask them, and in contrast to the suppliers, how many machines they bought and how their intention is, how many machines they will buy in the future or in the next year. It also provides us with a fairly good understanding of what is happening out on the market and on the shop floor. So we hear about new projects and developments, and in general, it helps us to put the developments into perspective and to provide the reader with the right context for certain developments. So using the previously mentioned installed base, where we assume, where we cover the full market in metal additive manufacturing, we have a user coverage of about 10%. So this means that we know where every 10th machine today, metal additive manufacturing machine, is based at, and to a certain extent also what it does, how it runs, with what material it runs. And this puts a lot of the prediction of suppliers into a good perspective, as the the supplier numbers are, due to the nature of positive outlooks that they have. Sometimes the supplier expectations are a bit exaggerated. So this is something that we use throughout the report to match the expectations of the suppliers with the users. And sometimes they do match well, but sometimes they do not match. And then it's interesting to understand why there's a discrepancy in this data coming back from the market. Further segmentations that we use in our report are the region. So we mostly focus on the three main regions of the world: the Americas, which is today in additive manufacturing dominated by the US, with I would say more than 90% of the total activity. Then we look at the Asia Pacific region, as well as the EMEA region, which is more or less dominated by all the European countries. For some evaluations in our report, we also break down the data to a country level. This is, however, not available for all the aspects of the report. One reason is also that AM is still a niche technology in the overall manufacturing world. Next segmentation is the technology. So in metal, this is the main alloys, the main technologies such as powder bed fusion, binder jetting, powder or wire, direct energy depositioning. There will be an example later in one of the slides. And in polymer, we also similarly segment into the technologies there. So powder bed fusion, resin-based technologies, material extrusion, just to name a few. For the materials, we divide into the main metal alloy groups, such as stainless steel, tool steel, titanium, nickel-based alloys, or copper, for example. And similarly, also in polymer additive manufacturing, we also divide there into the main polymer groups. And last but not least, the last segmentation is the industry, where we of course consider the main verticals, which are of course today such as civil aviation, defense, space, automotive, transportation, medical, dental, general engineering, and so forth. I will also have an explanation later or showcase where we show the different verticals that we consider for our data. So let's start with the results of our market data analysis. We group our data of the suppliers into 3 different groups, which is the system suppliers, the material suppliers, as well as the part manufacturing service bureaus. So you can see the different shades of blue on the graph. The group of part manufacturing service bureaus does not include OEMs and Tier 1 suppliers, because we account those as revenue generated in different industries, not the AM industry. So this revenue generated by OEMs of part manufacturers will go to the direct vertical of the OEM, which we do not consider in our report. An example is a hip cup produced by a medical company. So we do not record the sales value of the hip cup at the end of the day. For the combined metal and polymer AM market, we evaluated the market to be at about 7 billion euros in 2020. And the system suppliers make up about 1.8 billion euros for this. Material accounts for roughly 2.3 billion, and the part manufacturing service bureaus had a revenue of around 3 billion euros. Our outlook period is always 5 years. We limit it there as we find anything beyond that to be unreasonable guesswork. So we limit it at 5 years. And the suppliers from the market now currently expect, and this is their outlook, an average annual growth of about 20%. So the average supplier says in 5 years we will have a growth of 20% in each year. So the total market for polymer and metal AM will arrive at around 17 billion euros in 2025. And in 2025, it will be split by about 1/3 between the system suppliers, the material suppliers, and the part manufacturing service bureaus. Looking at metal and polymer, the market is also at quite different stages. So the polymer market is much bigger, first of all. According to our evaluation, it's around 5 billion, whereas the metal market is only around 2 billion euros. And in polymers, half of the revenue in polymer is coming from part manufacturing services. In metal AM, this revenue is only at about 1/4. So the part manufacturing service is much more developed in the field of polymer additive manufacturing. So coming to the next slide, this slide answers what are the major industries of AM, looking at the system sales revenue in 2020. So in this graph, you can see the different segmentations we use for the industry throughout our report. We changed this a bit, or we have changed this a bit every year now. First of all, to represent the market better, to represent the developments of upcoming new verticals that profit from AM and adopt AM faster than others, but also to accommodate certain requests we have from customers that would prefer different focus points. So we are open for suggestions on how to further improve our representation of the data. once you look in the report and you have suggestions, we're always open to discuss this for the coming reports. So looking at the sectors where metal and polymer AM machines were sold to and where the revenue was generated, we see that medical is leading with 19% of all the revenue. And the follow-ups are the defense and space industry. And especially the space industry, as Matthias already mentioned before, had a remarkable year in 2020, led by very strong activity in the US. And despite a very difficult year in general, the automotive and transport industry was still responsible for about 10–11% of the revenue with industrial AM machines in the last year. As AM is also still quite research-driven technology with many new innovations and developments, I guess it's not too surprising that more than every 20th machine still goes to public R&D institutions and universities. So making up for about 6% of the revenue. So let's take a look at the technology segmentations that were used. This is combined for metal and polymer. This graph shows combined for these two groups, the distribution of the revenue of sold machines in 2020. Of course, in our report, in the full report, this is also separated in metal and polymer with much more details. This is merely an overview here. So overall, the powder bed fusion is by far the leading technology with about 40% of all the sales. In metal alone, it makes up more than 90%, more than 80% of all the sales. So it's even more present there. So powder bed fusion technology takes up a large chunk of all the AM technologies. Filament material extrusion is, let's say here at only 16%, but I would like to mention here again that we only take into account the industrial systems that have a sales price of beyond 10,000 euros. Moving on to the next slide. Sorry. For the coming couple slides, I would like to focus only on metal, the metal AM sector. So before we had polymer and metal combined, now it's only metal additive manufacturing on these coming slides. So for metal additive manufacturing, looking at the overall market and the historical data, we can see that since 2016, we had a increase to 2019 of yearly growth of 32%. So quite strong growth over the past years. And in 2020, the whole industry experienced quite a big setback. So we had pretty much a flat line from 2019 to 2020 in metal additive manufacturing. And yet the industry had, of course, growth expectations of 20 to 30% starting in 2019. Major factor is, of course, the COVID-19 situation. Pretty much all the major industries were affected too, and this was a major deal also for a lot of the additive manufacturing world. Nevertheless, the market arrived at about 2 billion euros of revenue in total. The reason why there's also flatline is pretty much mainly due to the drop in system sales. So coming from the previous year, the system sales revenue dropped by about 15 to 20% to only 900 million euros in 2020. In 2019, it has passed the 1 billion euro mark. So while some of the established system suppliers were meeting similar numbers from the year before, sales numbers from the year before, we talked to companies that had reductions of more than 30% in their revenue, and some even had reductions up to 75%. So there's quite a few established and large players that struggles throughout the last year. So overall, some market players took heavy hits and continue to struggle. And we already see the consolidation in the market, and we've seen it before. COVID might lead to further activity in this consolidation direction. It will overall be interesting to see because some of the sales projects that didn't go through in 2020, some were only postponed, but it will be interesting to see how many will be now realized and how many will be eventually cancelled. If there will be a catch-up period in 2020 on the 2021, sorry, on the materials on the machine sales. The material market grew year on year. So we had higher material use. I mean, this is not too surprising looking at the increase of numbers every year of machines, which run, of course, more material every year. And now taking a look at the future, the suppliers predicts here a growth of around 30%, counting together the revenues of the system sales, material sales, and part manufacturing service bureaus. The market is expected to reach a size of around 7 billion euros in 2025. And these three supplier groups will make up about 1/3 of the total market. So moving on to the next slide, looking at the technology diversity, we'll see that in metal additive manufacturing again, it shows here on this graph the installed machines segmented by technology. So powder bed fusion had in 2020 a share of 86% of all the installed machines. So pretty much 9 out of 10 installed metal AM machines are allocated to the powder bed fusion technology. So it's by far the dominating technology in additive manufacturing. Looking at the sold machines in 2020, however, something that is not displayed on the chart here, powder bed fusion only accounted for about 75% of the machines, of the units. So it is a bit lower. This is mainly also due to the historic large number of powder bed fusion machines. What this graph also shows is the prediction of the suppliers. This is the middle bar. So what the suppliers believe what they will have sold until 2025. And the right bar shows the forecast of the users, what they plan to install until 2025, so over the coming years. Powder bed fusion is more or less at a similar level for both of them. Large differences are there, however, for two technologies. One is the laser and electron beam direct energy depositioning methods. Here we see a much higher anticipation of the users, a much higher adoption rate the user predicts. The users seem to be very interested in these technologies. They seem to be interested in buying machines and develop new applications. In interest, the suppliers have not yet picked up, so they are below the expectations of the users. On the other side, we see a much higher expectation from the supplier side in the field of metal FDM technology. So the outlook here is much higher from the supplier side than what the users seem to believe. So it will be interesting to see for both areas what will come true here and what prediction will be fulfilled, if it will be supplier or the buyer prediction or somewhere in between. All right. Also, can we jump back one slide, Matthias? All right. Something that is also remarkable here for this slide is something I missed mentioning, but I think it's worthwhile to discuss it, is the topic of binder jetting. In the past years, we've seen, especially when the first hype hit in 2018 in our first report, we had a much higher user expectation of adoption of this technology in the future. So the user expected a much larger purchase of machines than the suppliers predicted. In 2019, this completely shifted to the supplier side. So the suppliers had much exaggerated expectations for the future. And it seems that in 2025, now for the data we analyzed from 2020, that the future in 2025, binder jetting has quite a good match between the suppliers and the buyers of the technology. So it seems to have that both sides realized now what the technology can be used for and maybe also what it cannot be used for. So quite a mature analysis now on this technology aspect. Now moving on to the last graph on our market data, coming to just powder bed fusion in metal in general, and the outlook of how the sales numbers will be over the next 5 years. So this graph displays the development, as I said, only on the powder bed fusion market, and it shows the sales numbers of the machines over the past years in units. It has been declining from about 1,700 units in 2018 to about 1,500 units in 2020. So last year, 1,500 powder bed fusion machines were sold. So each of these years, the suppliers had much higher expectations for the next year than what was actually able to realize on the market, which of course led then to the consolidation. So overall, powder bed fusion system suppliers had difficult years. And the effect you can pretty much observe looking at any of the large powder bed fusion company that went through some sort of restructuring program over the past 2 years. I think there's not a single one of the established large powder bed fusion companies that didn't have significant changes in the management, in their C-level ranks, or that had some sort of layoff programs for their employees. And this was not necessarily due to COVID, but also initiated before. So we'll see how COVID will now even further change this situation in the future. So now looking at the future expectations that we see from our graphs, the predictions of the suppliers are in blue color for the report 2020 in the brighter blue, and the prediction for the Mpow report 2021 from the suppliers in a darker blue shade. And similar in green color, the expectations from the user side. And we can see that coming from the predictions of the report 2020, that the predictions for the report 2021 for these both groups are the gap is becoming much smaller for the future. So looking at the gap in 2024 and the gap in 2025 that we see, it has reduced quite a lot. So we experienced pretty much from our interviews with the suppliers that the predictions that they were giving out were much more conservative now in the last year. So this is maybe the main reason why we have such a small gap. In any case, the suppliers as well as buyers see a quite positive outlook on the technologies. They both project for 2025 that they will sell around 4,000 machines, and the users plan to buy around 3,600 machines. So there's still a gap of a couple hundred machines, but it's closing more and more over the last few years. So this was my presentation of the data. I would like to pass back to Matthias for some final words before we come to our Q&A session, where I'm happy, of course, to discuss any questions that you have, what was just presented now. So thank you.
All right, thank you, Max, for the presentation. We have actually one more slide to show to emphasize a little bit more into the field of upcoming technologies. We experienced in the past that 3D printing is continuously improving. We just mentioned powder bed fusion is the main industrial additive manufacturing technology, but there are lots of developments going on in terms of metal technologies as well as polymer technologies, and we expect that speed and cost are right now the driving factors of new developments, especially in terms of binder jetting. We see multiple players emerging on the market, maybe not as fast as some of them predicted. There are some takebacks because the technology is very complex. We all witnessed in the beginning of this year the going public by Seurat with their area printing technology, which will definitely have a big impact on laser powder bed fusion technologies. And also in the VAT area, in the liquid resin technology area, in the polymer field, there's a lot going on in there in terms of speed and new materials, sturdier materials, more industrial relevant materials being set up in this field. So we expect a lot of development in new technologies, and this will definitely not, laser powder bed fusion will not be the only technology in a couple of years that will have a major impact in industrial additive manufacturing. Now it's great to have some questions. The last slide we want to show is the Q&A slide. So first of all, thank you very much for everyone who was joining us today. And everyone who has some questions can now put them into the Q&A session. It is open already since the beginning of the presentation, and we have a couple of questions already in. I'm not sure if we are able to answer all of the questions. We blocked some time until 5 p.m. CET, our time here in Germany. We just try to go through most of the questions, and I will select some of the questions and most likely forward them then to Max or Eric. Max on his side is definitely the right guy when it comes to all the market crunching and going through the data, whereas Eric is our expert in terms of technology on the technology side. So let's go through some of the questions that we put into the queue already. Frank, for example, Frank Cohen asked, if you compare your projection of the metal AM market until 2025 and compare this growth with the growth expectations we have seen in the past month at some suppliers in the US, are you conservative or are they bullish on metal AM? I think this is the right question for Max. Do you have an answer on that?
The answer is probably not very satisfactory. The answer is probably not very satisfactory that I can give, as I think the sales number that were presented over the past quarter, if these are representative for the whole year, we have to see how the effects from last year, that some projects did not go through, some of the sales projects did not go through, will what kind of effect will it have on the full year? I think it's not fair to compare our outlook of the next 5 years with just one quarter from this year. This is why I kind of struggle with giving an answer here. All right.
Well, I think that we definitely see a lot more movements in the US. On the one hand, in terms of new companies coming up, Velo 3D, Seurat, Desktop Metal in the past couple of years, to just name a few. I think we see many more startups in the US than in Europe right now, so there's much more drive. And obviously there is more expectations coming from this side, but I think it's also accompanied with higher user expectations. The US in general seems to be lagging behind a little bit compared with the EU in the past, so they have more market potential still unserved, I would say, which was served by SLM Solutions and EOS in probably most cases in the past, and is now being served more and more by also local suppliers. We have another question from an anonymous. Hello guys, you predict a growth share of DED systems until 2025. Which industry specifically? I think this is also something for you, Max. What kind of industries do we see in terms of applications? I remember many interest being driven by aviation companies, aviation and space companies, also by the tooling industry. Do you have something to add?
This is the main industries, aviation, defense, and space, taking over or considering the use of these DED technologies. In general, the use and the interest from the users is picking up and is increasing in their interest. But also, I think that some of the, let's say, general engineering companies find applications now. They are a bit slower on the use, but they will find applications certainly as well. Other industries that shouldn't be neglected are like oil and gas industry or the energy industry that also uses the technology already today successfully. Some of the applications are not really well known, as these are, let's say, hidden users. So we can expect for this area quite a lot of pickup, but it's definitely probably driven by the industries Matthias already mentioned.
Yeah, I also agree, and I think we are also surprised ourselves by the interest that companies showed in a DED study that we published at the end of 2019, or we went through at the end of 2019, with, I think, almost 20 companies who participated in the study, and a lot more companies showed interest in it. So there's definitely a lot of interest across many industries, but definitely with a focus on aviation space area. All right, we have another question with 3 thumbs up. Oh, there's one with 4, I just see. How is the share between laser and electron beam in revenue of PBF systems? Well, maybe just a quick side note on this question, because it's maybe something worth noting what we didn't mention so far about our report. One of the key elements of our report is that we don't publish numbers of specific suppliers, of specific names. You might notice that other reports publishing, for example, sales numbers of EOS, GE, Trump, and so on. We agreed that we would rather like to have market numbers, sales numbers of as many companies as possible to be as representative as possible with our report data. Paying the price, though, that we are not publishing specific numbers of specific company sales numbers, machine sales. So this is the reason why we don't split the PBF revenue and the PBF sales in laser and electron beam, because if we would do so, it would very clearly publish the numbers that the only supplier right now in the market who has significant sales numbers is here Arcam, obviously. And this is the reason why. But maybe Max, maybe you can give some indication on that, or some more background information about how electron beam melting is developing.
Sure. I mean, right now the share is without telling too much, below in the single-digit range. It is laser powder bed fusion is by far dominating this field. It will be interesting to see now that Arcam has many more competitors that enter the market. With examples are Wayland, Additive Free Melt, Mitsubishi Electric published their machine, Geo just recently.
ProBeam,
a German company. So there's many companies that will enter the market that found a way around Arcam's very good IP situation with the electron beam melting technology. And once this also screams towards innovation in this sector, that many more suppliers will allow the development of new materials, new products, different kind of processes that maybe weren't possible with the Arcam machines. Not saying that Arcam did a bad job. It's just more competition usually drives innovation, and I'm looking forward to see this on the EB powder bed fusion market.
All right. There's another question with 4 thumbs up. I think it's a very interesting one about what about the second-hand equipment market? How will that impact things? I think it reminds me a little bit of a discussion that we had during this year's report analysis and assessment, that we actually found out that many machines are already out of service. So it's difficult. I think we discussed in the past already about installed base and totally sold system, which seems to be a different number. I'm not sure if we now changed the label of it, but it definitely seems like there's a lot of systems being exchanged now at some of the suppliers. Do you have some comment on this, Max?
Sure. I don't have exact numbers on this. It's something we want to consider more in the future. It will play a bigger role in the future. A lot of the users of the machine say that they will not increase the floor space for their machines, but they will exchange the machines for faster machines. And this will also then drive a second-hand market, because these machines are still running well. It will also be interesting to see that now some of the, let's say, older machines that are more than 10 years old are taking out of the servicing programs from the system suppliers. We have users that say these are the machines that run the best, and they would still continue to run it, but they don't get any service. So what do they do with the machine? Will there be a service provider that is maybe not sanctioned from the system supplier, that maybe found a way around it, that will still be able to service these machines and run them at a low cost at some other site? it will be interesting to see in the future how this will certainly develop.
I also remember we do have a chart in the report about multi-laser system advancement. And I think, if I remember right, but just correct me if I'm wrong, I think the user actually expects a higher number of multi-laser systems in 2025 than the supplier does, even, isn't it?
Absolutely. So the trend is definitely on the industrial user side that they will opt for the machines that have multiple lasers. It of course depends on the type of industry, whereas I would expect the smaller dental machines continue to run a single laser machine. But we see in many of the industries that are in production, that are in serious production here, the larger machines with higher productivity can reduce the cost of the individual part at the end. So these industries will adopt the higher productivity machines with multiple laser. And the race is opened, what we've seen last year from the announcements, 7, 8, 12 laser machines all around. So it will be interesting to see how the users will adopt these machines.
All right. So we have another question from Pete. I'm just scrolling through the questions with most thumbs. PBF dominates from a system sales revenue perspective. However, powder bed fusion, let's keep scrolling down. Powder bed fusion systems can be quite expensive. Which technology had the most unit shipments, and to what?
Sure.
And to what industries?
So
that's something clearly for you.
Sure. The powder bed fusion systems have in total the most system sales, and they have the most revenue still at the same time. It's simply in metal additive manufacturing. If we just focus on this for a moment, it's just the dominating technology. What's interesting to see in the powder bed fusion sector is that for metals, the average price of the machine is very regional dependent. So what we see in the US or in the APEC, in the Americas region, in the EMEA region, the average price of a metal AM machine is around 450,000 euros. I don't have the exact number in my head right now. And we see on the APEC market a lot lower average machine price with a lot higher units. So we have an average machine price of only around 350,000, mainly due to the use, for example, in China, of local components for the local machines instead of opting for more costly laser systems or optical systems. In the polymer area, here the differences are of course bigger. Powder bed fusion does not have or does not reach this this market share here. We also see a lot of the other systems grow in number, and we also see here that powder bed fusion does not reach this kind of domination. Still, the machines range in cost from 100,000 to 400,000 euros, but we also see an introduction in powder bed fusion machines on the low cost end for only 10 to 20,000 euros that now come on the market. And this is a trend we overall see, that we have a larger range of powder bed fusion machines. We have the low cost machines for only 10, 20,000 euros in polymer. We also see the introduction of powder bed fusion machines on the metal side below 100,000 euros. But we also see on the other side the extent of the range to be increased with the very large machines with multiple lasers. So the range simply for powder bed fusion will increase even more in the future.
All right. There's a question regarding binder jetting. It's maybe one that I can help with. Metal binder jetting is growing at an okay pace compared to others rather pessimistic projection. What are your reasons for that? Yeah, maybe that's something that where I can step in a little bit, because I'm also working on the internal or the study we're doing right now with about 15 participating companies focusing on binder jetting. binder jetting, to our experience so far, has a huge potential to be a very, very cost-efficient additive manufacturing technology, but it comes at the cost of being a very, very complex technology, and that complexity we don't see being solved in the next 5 years, which means we see it rather in the process of being solved within the next 5 years, meaning that many companies now invest in a single system to explore the potential, or they're starting investing in parts and test parts and developing applications, learning about the technology, but that doesn't happen overnight, and that's just at its beginning. The users we talk to, they're all interested and eager to learn about the technology, but it takes about 5 years. That's actually a very good time frame, I think, for users to understand the technology, to make full use of it before they start really investing into more than one machine. So we currently see most users either investing in a small setup of one machine with a furnace to make their first experience, while others are trying to find suppliers on the market who can provide them with parts while they're doing their application development. So maybe in 5 years the pace will keep up if users manage to control this very complex technology. It's not just complex because of the sintering process, but it's complex through the whole process chain. Actually, it's complex in terms of a big impact of the material choice of the powder quality. It has a big impact on the sintering process, has a big impact on the quality of the part, on the density, on the chemical composition. The sintering process and the design are very complex in exchange because of deformation effects. So it is complex, but it has a high potential. But I think, or we think, in 5 years is maybe a step where most larger companies invested in 1, maximum 2 machines. Some suppliers will have stocked up with a couple of machines or lines with sintering furnaces, and maybe until 2030, the numbers or sales numbers for binder jetting systems will significantly increase. Something to add from you, Max, maybe?
Nothing to add from me.
Frank Nachtiga is asking, what's the next big thing in AM from your perspective? What is the next big thing, Max and Eric? One of you has some comment on that.
I can start with my opinion. Eric can maybe follow up. So for me, looking at powder bed fusion, I mean, it's already out there, but the next big thing is seeing how good the adoption will be of the very large, very productive machines on one end, but also how and to what extent these smaller machines that will that are now entering the market below 100,000 euros will change the whole price level and maybe change the adoption and cost of the technologies.
Eric, your turn to add something.
Yeah. I also see the possibility on how the existing technologies will actually be incorporated into the general industrial supply chains and not stand alone as production technologies, but will be introduced in the whole digitalized production chains of the companies. Regarding next through big things of new technologies, I think there are some very interesting technologies out there. You just mentioned at the beginning of this year this area printing in the area of laser powder bed fusion. If this technology can be commercialized and get away from this prototyping state, this will be a breakthrough, next big thing. And also the adoption of the DD technologies on a much wider base will change many things in the AM world.
Okay. Next question. Do you expect that metal binder jetting will achieve the necessary quality level for regulated markets? Example gives medical aerospace in the near future, 2 to 3 years. Maybe let me begin by mentioning my impression on binder jetting users that are currently developing applications for metal binder jetting. They're, from our experience, not mainly coming from medical or aerospace fields. Our experience is that both those industries heavily invested in laser or electron powder bed fusion technology and developed applications, developed standard specifications for those technologies, for powder bed fusion technologies. And it's, from our perspective, just very unlikely that they will change this invest very quickly into another technology, into another direction. They identified applications they can earn money with, they identified real business cases with those technologies. So there is not a big need to now invest into a completely unknown technology to many users. So probably it is, the technology can achieve this quality level, but since the users are not driving it right now from those regulated markets that you mentioned, there are other regulated markets. Obviously, also an automotive market is somewhat regulated, just in another area. So in those fields, but in the near future, 2 to 3 years from our perspective is way too optimistic. I don't know, Max, if you want to add something that
I would add something for the medical field. Aviation, I see, I'm a bit more pessimistic. Also, the need for this technology in this field for large and small parts, smaller parts and large batch sizes. In medical, you can look at metal injection molding that has its uses, for example, in producing titanium implant devices. So the quality level can be used or can be reached with metal injection molding. And once it can be reached with metal injection molding, I think there's no argument against it why it can't be reached with binder jetting. It's just a matter of time and finding the right application. And if you find the right application, the right cost level, so it's worth of investing a lot of resources in developing this over the next few years, there's nothing that speaks against it. But there has to be a certain business case. There has to be a need for binder jetting that the user benefits from it at the end of the day.
All right. Markus Köhler is asking, thank you for the great work. Is there a section covering research activities in particular at universities in your report? Yes, there are 3 contributing authors who wrote articles about local developments for each region. So we have, Max, correct me if I'm wrong, we have the European region, we have the US, North American region, and the Asia Pacific region covered in terms of R&D activities that happened in the past year. But that's the main focus on universities as far as I know. Correct me if I'm wrong, yeah. Max.
This is from the guest authors that write an overview on what happened throughout the last year. This is in one of the regional sections. And we also cover, of course, the university activities, but more how many machines were sold into this, let's say. Also, it's a type of vertical, but we do not cover what was actually done with these machines in university. This is, of course, very fragmented and not easy to describe in just a few words.
All right. Do you believe, Christian is asking, do you believe the core COVID impact has already hit the market in 2020, or do you believe there will be a delayed effect into 2021? I think that's difficult to answer. I think that the big impact on system suppliers in the last year was not necessarily so much to orders that didn't come in, but also a lot to with regards to machines that couldn't be installed. How do you see that, Max?
I see it in a similar way. Very difficult to assess if there will be a delay. This is more on a belief how the general economic situation, how well the recovery will be. This has not so much to do with AM, I would say. We will see a bit of delay in all the activities as R&D projects were cancelled, as aviation people were laid off. So there will definitely be a long-term impact as well. But now looking at the economic situation, that will pick up very fast, I assume, in the US again, and sooner or later in Europe as well. I would say we can say that probably the large impact has already been there.
Yeah, I think I would agree. Also, most of the suppliers and most of the users as well we talk to are rather optimistic right now. I think big parts of the industry also suffered less than some people expected it to suffer in the general industry. So I think we all hope that it will only have a small dent in 2021. Will simulation play any significant role for effective metal AM? Well, I think this is a question that needs to be specified maybe regarding a specific technology. Simulation of what is the big question? The simulation of the process of the laser powder bed fusion process, I think, is very well established and also being used across industries and also across the part manufacturing suppliers as well as the users. We see simulation of the laser powder bed fusion process everywhere. For binder jetting, again, it's a major enabler to control deformation, to pre-deform the parts, compensate for sintering deforming during the sintering process. So I could say from my side that simulation is already playing a significant role in effectively using additive. How do you see that?
I would agree. It is used and has been used for the last years. Topology optimization, process optimization, and binder jetting, and sinter-based in general in metal. This will continue to be a key and enabling factor for this technology. So simulation will be and stay an important tool also for the assessment of the properties of a part. If you want to produce something in low batches, simulation will be the go-to in the future.
All right, it's almost 5 p.m. I think we have 2 more minutes. I would say this is the last question we will go through from Tobias Grimm. Will the growth in material costs be caused by more volume of existing materials or by new materials? I think that's a very interesting question. Max, I think it's definitely for you.
The growth that we see will be in volume from the already established alloys. This is simply the growth will be since these alloys are developing with these alloys the new applications that will then be driven into a series production, and only then you will reach the large volumes. But having said that, there will be more diverse material development in the future. Each technology will need, and maybe also the service providers, they will need to find a certain niche where they are successful. Powder bed fusion, just looking at metal, has let's say untapped potential in terms of materials, where this technology will enable new materials, new applications. So it will take, however, a few years, and I don't know if we are there yet in 5 years to see a major growth of a certain new material. This will take a while. If you look at new material types like metallic glasses or the high entropy alloys, there's so much potential, or carbides, there's so much potential just on the metal side, where we simply don't know what will be possible in the future. And then we can, once we know this, we can assess what the outcome will be. But it's so much development going on that for the expectation right now, it will be the alloys that we already see on the market today.
All right. Good. It's 5 p.m. Time's up. Thank you for all the visitors, for all of you who joined us in this first event. For us, it was the first time. I hope you were all able to see and hear as well. Thank you, Max, for your answers and for your presentation. Thank you, Eric, for your support. Thank you, Timo, our new employee who helped us a lot in the polymer section. Thanks very much. We're very excited that this report is finally out. Don't miss to just go on our homepage. You can download a free report summary. Most of the graphs that you've seen today are in this report summary. I think some of the graphs were exclusive for this presentation. I hope you all liked it. Just drop us an email if you have any further questions about the report. And we hope to see you all at Formnext in real life again. Unfortunately, we cannot make it to AMAC, which is starting soon. But I think Formnext is really the next big event that we all hope for. Maybe the Additive Manufacturing Forum in Berlin for our German community here. Thanks again. Thank you very much for joining us. Hope to see you all soon.